Hello, Algebra 2. This is the last check for LFR7. My hint to you, or not my hint, my suggestion is that when you're going through this thing, pick the methods that you're going to do first. Make sure that you've got at least one graphing, one elimination, one substitution, and then pick the last one, okay? Make it easy on yourself. Don't start them until you've done the solving method and the reason for why you're doing that method. All right, with that said, the first one, I'm going to go through these on my own. I like graphing for the first one. I like graphing for this one because it's already in slope-intercept form, making it efficient to graph. Already in a form that's efficient to graph from. Whoops. To graph from. It's already in a form that's efficient to graph from. Okay, that's what I like for number one. For number two, again, you can solve all these using any way, in my opinion. And again, it doesn't, you don't have to follow what I do. I'm just telling you, you got to use every method. All right. What I see the fact that this is already X equals. I see that's already X equals. And what I would do substitution. Could you graph? Yeah. Could you do elimination? Yeah. I see this one as a substitution. Substitution, the reason being, one equation is already solved for one variable. And that's the first step. That's the first step of substitution. It's already been done for you. So I see that and I like that. Let's look at number 3 and number 4 real quick. Number 3, substitution or elimination. I see both. You could do graphing too, because this one would be a nice one to do some finding the intercepts with and plot those and graph the lines there. That would be a good one to do there. But for this one, what I see this one as elimination. Could you do substitution? Yeah, because I could take this second equation and solve for X very efficiently. But the reason that I have picked elimination in this one is because I see right away that if I multiply or divide the equation, if I modify the equation, I can efficiently eliminate a variable. If I multiply an equation, I can efficiently eliminate a variable. If I multiply an equation, I can efficiently eliminate a variable. And for number 4, right here, I immediately see elimination, because if I add those two equations together, I get rid of y. I eliminate y. So again, I'm going to choose elimination here. If I add the equations together, I can eliminate y. I can eliminate a variable. Okay, so let's go ahead and go back and let's knock these out then. Let's start with 1. Number 1 is in slope-intercept form. So I'm going to plot my y-intercept for the first one, which is 1. Use the slope to find additional points. I could rise 1, run 2. rise 1, run 2. I could go down 1 and left 2 also. Still would give me the same thing. Keeps me on the same line here. The second one, the y-intercept is -2. This slope is 2 or 2 over 1. I could rise 2, run 1, rise 2, run 1, rise 2, run 1. And very efficiently, that is where they cross. Graphing falls short. Where graphing falls short is if it's like, partials. When graphing is nice, it's right on the nice intersection of points. These cross at 2, 2. That is my solution, and I did it by graphing. Let's look at number 2. Let's look at number 2 now. I said substitution. So anywhere I see x in the second equation, I'm going to put in parentheses. Please put it in parentheses so you remember to distribute the whole thing through. I've got 3 minus y equals 2 times x, but instead of writing x, I'm going to write 3y plus 12 because that's what it equals. X equals 3y plus 12, so I'm substituting it right back into there. If I do this, I have 3 minus y equals 6y plus 24. I'm going to do some magic here. I'm going to add y to both sides, and I'm going to subtract 24 from both sides. I'm going to do this in one step. I get -21 equals 7y. Divide both by 7, both sides by 7, and y equals -3. But we also need the x value. Don't forget that. Y equals -3. And it just so happens I have an equation that says x equals 3 times y, and y is -3, plus 12. So this is -9 plus 12, which is 3. X value is 3. 3, 3. Again, yes, I'm going a little more quickly through this one because this is the last check. This is the culmination of all the things that we've been doing. Number 3. Go back up to number 3. I like this one right here. I really like this problem. I see that if I multiply that bottom one by 4, I get 4x plus 12y equals 36. If I multiply the bottom one, I get 4x plus 12y equals 36. That's funny. And why is that funny? That means they're the same line. It's the same line. If they're the same line, how many times does the same line touch? Well, infinitely. Infinite solutions. I like that one a lot. Let's look at number 4. Number 4, we said we're going to do elimination. So go ahead and get rid of this business. If I add these two equations together, I get 6x plus 0, I'm not going to write that in, equals 18. Divide both by 6 and x equals 3. So I've got x equals 3, comma, and then we got to figure out what y is. And it doesn't matter which equation that we plug it into, but what's really, really, really nice is that that bottom equation is all positive numbers. Let's roll with that. 2 times x, we said x was 3, plus 3y equals 9. This is 6 plus 3y equals 9. Subtract 6 from both sides. 3y equals 3. Divide by 3 and y equals 1. These two lines cross when x is 3 and when y is 1. This is my solution. I need it in that coordinate point. Let's go ahead. Let's look at that 4-level example. It says a cable television provider has a $55 setup fee and charges $82 per month, while a satellite television provider has a $160 setup fee and charges $67 per month. Let C represent the total cost in dollars and T represent the amount of time in months. The system of equations C equals 55 plus 82T and C equals 160 plus 67T can be used to represent this situation. And how many months will both providers cost the same? When will C equal C, or when will 55 plus 82T equal 160 plus 67T? You could do substitution, you could do elimination, you could graph if you wanted to. I'm just going to do substitution in this case. I like to deal with positive values, so I'm going to subtract 67T from both sides and 55 from both sides. That gets rid of this, goes to 0. This is 15t. This is 105, and this is 0. This is 0. I get 15t equals 105. Divide both by 15, and t equals 7. Fantastic. We know t is months. T is months, so it's got 7 months. And what's the cost? So the cost, and it doesn't matter which equation we do, c equals 55 plus 82 times 7. So this is 55 plus, let's see, 560, 574. Add those together and you get 629. And if we wanted to be thorough, we can check 160 plus 67 times 7. So that's 160 plus 42, 469, which is still 520, or I'm sorry, 629. 629. So in other words, it says, in how many months will both providers cost the same, and what will the cost be? In 7 months, they will both cost $629. Part B says, if you plan to move in 12 months, which provider will be less expensive? Well, if we look at here, after 7 months, the top one, this is cable television, remember. The bottom is satellite. And it turns out that that top equation after 7 months becomes more expensive. So we're going to go with satellite because it will be less expensive after 7 months. Less expensive after 7 months. There we go. That's it. That is LFR7 in a nutshell. Hope you guys have a great time, great weekend, or great day, whatever time you're watching this video. So yeah, take care. Talk to you soon.